Here are the video notes to go along with 9.2.1 and 9.2.2. Do keep in mind, because these two sections are being paired together, you won't get another video for the 9.2.2 lesson. So if you need a refresher, come back to this one. All right, so here we've got stuff up at the very top of our notes. And so what we want to do is just kind of take a look at the very top stuff. So I'm going to go through and follow the directions, which I will not read at you still, but I am going to highlight some stuff. So let's see how dark this comes out. Okay, there we go. So when I'm thinking about whether I'm going to have a solid boundary or a dashed boundary, I'm going to kind of go back to what I had done previously. So if this was just a single variable, so for example, if I have like x is, oh, that's too thick. Let's bring that down a little bit. Say I have x is less than 4. Then that less than part would tell me on the graph at 4 that I would have a hole in the graph, so like an empty dot. And then, of course, I'd kind of be following the arrow tip. So, but in this case, because I'm graphing it on a coordinate plane, if I have that less than or greater than, so there's no equal to, I need to show that I have like a hole at the boundary. So the same idea of having this little opening right there on the graph. So for us, what it's going to end up being is a boundary that has holes in it. So chunks are missing. So this is going to look like a dashed line on the graph, or dashed boundary. Whereas on the other one where it was solid, so let's say we have x is greater than or equal to 2. So for example, if we graphed that, then we know we would have a filled in dot. So it would be a solid boundary and then kind of following the arrow tip. So kind of the same idea of what we did before with the like a boundary not included. So we'd have like a little hole there, or the boundary that is included and we'd have a filled in dot. It's kind of the same rationale here. And then when we're talking about being able to figure out where the shading is, or where's the solution, so on the number lines, where would the arrow be pointing? It's not quite as simple as we can just follow the tip of the arrow. It would be nice, but it's not. So what we're going to do is we're going to test a point on one side of the graph and then see if it works or not. So first things first, take a look at this example. The very first thing I'm going to do is I'm going to rewrite this as y equals. So let's do y, let's get rid of the highlighter there. Let's do y equals negative 2/3 x plus 2. All right, so I know my y-intercept is at 0, 2. So I'm over here on my graph now, and I'm plotting the point 0, 2. And then I have a negative 2/3 slope. So when we have a negative slope, you guys know that you can either put the negative sign on top of the fraction or on the bottom of the fraction, doesn't matter which one. And I'm actually going to do it both ways. So starting from this point, I'm going to go down 2 and then right 3. So down 2, right 3, and I'm going to plot that point, and then I'm going to do it again. So down 2, right 3, down 2, right 3. And then I'm going to go up the other way as well. So from the other point, I'm going to go up 2, left 3. So I should have all of my points kind of lining up. Okay. Now, before I connect the dots, I'm going to go back to the question, and I'm going to look at the inequality symbol. Notice that the inequality symbol does not have an equal to part. So then that means that the boundary for this, so when I connect the dots, I am going to be creating it where it's got like chunks missing in it. So I would go through and I would start doing my dashed line. So I want to see chunks that are missing. Oh, that guy's off a little bit. So I want to see chunks that are missing there. So my boundary's not included. Okay, so now I have to be able to test. You are either going to test below the line, so over here somewhere, or you can test to the right or above the line, somewhere over here. It's up to you. Like, you guys know me. I love to test 0, 0. So it can't be on the boundary. So I see that 0, 0 right there where I put my orange circle is not on the boundary, so I can actually test that. So as I test the point that I'm choosing, I have to plug it all the way back in to the original where I still had the inequality symbol. So 0 is less than negative 2/3 times 0 plus 2. All right, let's see. So I'm going to get 0 is less than, okay, anything times 0 is just 0. 0 is less than 2. Okay, now at this point, I need to ask myself, well, is this true or false? If this is, so let's identify 0 less than 2. Yeah, that's true. So that means that my point 0, 0, that worked. So if I go back to my graph, you'll notice that 0, 0 was on this side of my line. Well, that is where all of my answer is going to be. So everything in that direction from the line is going to be my answer. So everything down here is going to work. So all of the points in that region of the graph are technically part of the solution. And I do like to kind of shade as much of the coordinate plane as I have with regards to that. And that's actually my answer to this. So the answer, when I'm given an inequality with both x's and y's in it, the answer is technically the graph. So it's the boundary and the shading. So if you want to lightly shade with your pencil, you're welcome to. Okay, so we've got a couple more problems, and this is basically the gist of it. This is what we're going to be doing. So the first one, much like the other one, I'm going to go ahead and turn it into y equals 4x minus 5. And this we know how to graph. So I've got my y-intercept of 0, negative 5. So 1, 2, 3, 4, 5. My slope is 4, so 4 over 1. So I'm going to go up 4, and then I'm going to go right 1. So 1, 2, 3, 4, 1. And then I'm going to do it a couple more times. And I do like to have a decent amount of points on my graph, personally. All right, so now at this point, I'm going to go take a look at the inequality symbol that was given to me. Notice that there is an equal to part. If there is an equal to part, then that means there's no holes in the graph. So I'm going to go ahead and connect this with a nice solid line. Okay. All right, now we need to test a point. Now, I love testing 0, 0, but you don't have to. You can kind of test whatever you want, just as long as it's not on the line. So, I don't know, let's test negative 1, 1. And I do like to mark it on the graph so I know where I checked something at. So I'm going to test, and then I'm going to do negative 1, 1. So go back to the original and plug in what you're testing. Okay. So that gives me negative 4 minus 5. And that's going to give me negative 9. Okay, so I asked myself if this is true or not. So is 1 greater than or equal to negative 9? Yeah, it's the greater than part. It doesn't have to be the equal to part. It's the greater than or equal to. So yes, this is good. So that means that wherever this point is located, it worked. We'll notice that this point is over here. So that means I'm going to shade in that direction. So everything in the same direction as that guy. Now, we don't want to check all of the points because honestly, that's impossible. there are an infinite amount of answers over there. It's kind of like when we did the number line. We didn't test all of the points, or even if we did test points, we would only test one, either on one side or the other. It doesn't have to be every single point you can imagine. Okay, so this is a perfect time, since we've already done a couple of them, to go ahead and pause the video. See if you can do this next question. Pay attention to where your y-intercept is located and what your slope is. Decide if your boundary is going to have holes in it, so like a line that has like chunks erased, or if it's going to be a solid line. And then I want you to see if you can test a point. I'm going to go ahead and pause and work this out, and then when you're ready, unpause the video and see how you did. Okay, so I've gone through and I've graphed this, but this is the first situation where I checked a point and it didn't work. So I thought I would unpause and kind of explain what I'm doing here. So I circled 0, 0. I put it into my equation and I noticed that it didn't work. So I don't want to start at the boundary and go towards the point that I circled. I actually want to go in the opposite direction. So if 0, 0 worked, then my graph would go that way. But it doesn't. So I'm actually going to go the opposite direction. So I'm going to go away from the point. So then my shading would actually be down here. And then that would be my answer for this. Okay, next one that I have here are just a reminder of kind of some of the oddballs, the ones that we haven't really done in a while. So just kind of a reminder of how to graph something like this. So if you have one of the variables only and the other variable is missing, when you graph these on the coordinate plane, you're either going to get a vertical line or you're going to get a horizontal line. And there's a couple of ways to remember it. So there was a mnemonic device that I gave you guys first semester, Hoivux. So if that helps you, then that might be something that you want to refer back to. If not, there's another way to do this. Actually, there's a whole bunch of different ways to do this. So I want you to imagine going up to, so the coordinate plane that they're giving you. So let's say they're giving us y, so the variable that they're giving you. I want you to go on the y-axis and go up to 4 and plot the point. It's really all we're going to do here. So I'm going to go on the y-axis and I'm going to go up to positive 4. Okay, from there, we now know, the only tricky one is the 0 part. I now know what axis it's going to hit, and the only axis it's going to hit. So if this is y equals, the only axis it's going to hit is y. The only odd situation about this is if you are dealing with equals 0. So if I go back now to the question, pay attention to the inequality symbol here. The inequality symbol does have an equal to part. So when I go through and graph this, I am going to go ahead and graph it without any holes in it. So I'm only hitting the y-axis. Now, from here, do what you normally would. Go ahead and find a location to test. So I'm still a big fan of 0, 0, so I'm going to plug 0, 0 in. So I'm still going to test 0, 0. Go ahead and plug that into the question. That's going to give me 0 is less than or equal to 4. Notice I'm not plugging an x in because there's no x in the problem. So this might actually be a little bit more straightforward than the others. So 0 is less than or equal to 4. Yes, this is true, which means 0, 0 worked. So go back to my graph, start at the boundary, and I go towards 0, 0 because it worked. Now I'm going to shade everything in that direction. So starting at the boundary, and then go towards that point. Okay, next one's kind of the same idea. So now would be a good time to pause. Think about it this way. Notice that there's only a single variable. So plot that value on that axis, and then it's only going to hit that axis. It should give you an idea of whether the line is going to be vertical or horizontal. And there's my graph for question number 5. So we had 3 problems where it was like y equals mx plus b. And then we had kind of the oddballs that we haven't really talked about too much recently. And then on our next and final slide, just a little bit of the review of kind of the exponential graphs that we did as well. So let's go ahead and take a look at these guys. The process is the same. I'm just going to go ahead and rewrite it as y equals. And then from there, I'm going to use the tools that I have done in the past to be able to graph it. Okay, so, and this actually looks, it's kind of hard to read. Let's go ahead and write that a little bit bigger. Y equals 1.15 to the x. Okay, so from here, whenever we're doing exponential graphs, I'm really only expecting you to do a couple of things, to be honest with you. One, I want to know what the 0th term is. Well, the beautiful part about this, for us this whole year, is going to be really nice, is that the 0th term so far, so we are going to have some that are going to be a little bit more complicated. So far is going to be that guy in front. So I know that I have the point 0, 4. So I'm going to go ahead and plot that first on my graph. So 0, 4. I also know, it's kind of a little sneak peek at some other stuff that's going to be coming actually in a couple class periods. If you take a look down here at the very end, notice that there is nothing being added or subtracted there. So if I wanted to add or subtract a number, then the only number we know how to add or subtract that doesn't do anything is 0. That right there is going to be your asymptote. So remember we talked about that invisible boundary. So this is going to tell me where my asymptote's located. Now, whenever we're talking about exponential, it's always going to be a y equals. Okay, I want to definitely put my asymptote on the graph. So I'm going to go over here, and I'm going to go to where y equals 0. Okay, so here's one of the tricky ones. Okay, so we're going to go on the y-axis to 0, and we're going to plot that point. So kind of using the same rationale that we did before. But we want to hit the y-axis. The same idea. So this is where that Hoivux comes in, which you really might want to use. If you have a y equals line, so as a reminder, our Hoivux part. If you have a y equals line, then we know that the graph is going to be horizontal. So it's going to go sideways from left to right. So from here, I'm going to go ahead and put on my y equals 0, my asymptote. It is a dashed line. It is a boundary. So it's something that your graph can get super close to, but it never actually gets there. Okay, and now there's really only one other thing I expect you to be able to do when it comes to being able to graph this. We're going to go take a look back at the equation again. I want you to take a look at the number inside. So the 1.15. So the guy who has the exponent. If that number, so if this guy is bigger than 0, no, let's do bigger than 1. Let's be a little bit more specific. If this is bigger than 1, then that means your y values are growing. So they're going to start low on the left-hand side, and then as you trace the graph, it's going to get higher and higher and higher. So here's what I mean. I'm going to start low on the left-hand side. Then my y's are going to get bigger and big. Make sure you hit that point. Bigger and bigger and bigger. So if it is bigger than 1, so the guy inside, then you're going to start low on the left and you're going to get bigger and bigger and bigger on the right. Okay, so now we have our graph. Now that we have the graph, we're going to go back and do what we just said a few minutes ago on the previous slides. We need to figure out where we're supposed to shade this thing. So as long as you don't pick something on the blue boundary, I need to make sure that this is correct. And I don't believe it is. Let's look. If I look at my inequality symbol, just highlighted in yellow, you'll notice that there's no equal to part. So I'm going to grab my eraser, and I'm just going to erase little chunks of my blue graph. So I'm just going to go through and erase little pieces of it. So I want to make sure that the boundary has holes in it. So I got to make sure that it is dashed. So I'm just erasing little chunks of it. Which, if you forget, kind of like I just did, to make sure that your boundary is dashed instead of solid, just grab your eraser and erase pieces of it. Okay, so now we need to check some points. All right, just as long as it's not on the blue graph. So since I wasn't super accurate like I was when I was graphing lines, my recommendation is just make sure that you choose a point that you're going to plug in that is obviously not on the graph. So don't choose something close to the blue curve. Don't do that, because who knows? We really only sketched this. So I am happy checking 0, 0 because it's not even close to the blue curve. So I'll go back here and I'm going to test 0, 0. So now I'm back to the inequality part. All right, so I'm going to get 0 is greater than 4 times 1.15 to the 0 power. Okay, a reminder about exponents. Remember, whenever we have something to the 0 power, so that guy right there, not including the 4, it's only the 1.15, then that is just going to be 1. And I got 4 times 1, which is 4. Okay, now I ask myself, is 0 bigger than 4? No, that's not true. So that means that this 0, 0 didn't work. So I don't want to go towards the 0, so that would be here. I don't want to do that because it didn't work. I want to go on the opposite direction. So it kind of looks like I'm inside the blue curve instead of on the outside of it. So I want to make sure that I am this way on the blue curve. Okay. And so that's my graph for this one. You'll notice that my graph is the orange shading, the blue dash, and the green dashed boundary as well. Okay, so let's go ahead and do this next one. And the same idea. So what I'm going to do is I'm going to take this, I'm going to turn it into an equal sign. Y equals 2.4 to the x. Okay, same process. Now, I know that at this point, so things might be changing in the future, that is going to be my 0th term, so 0, 2. I also know, by looking at the green part of this, that there is nothing at the end, which means if I put a number there at all, it would be plus 0, which means that is my asymptote. And it's always going to be y equals. It's always going to be horizontal whenever you're dealing with an exponential graph. Okay, so let's go ahead and plot this 0, 2 point. So 0, 2. And then let's go ahead and put in the asymptote. So I plot 0. Whoop. And then I want to put my dashed line through that. Okay, now I'm going to go back to the equation. And I'm going to take a look inside to see if this thing looks like it's going to be growing or if it looks like it's going to be shrinking. So if I look inside the parentheses now, that is actually it's still got to be positive. I think we talked about that, a while ago. But it is smaller than 1. If it is smaller than 1, then that means your graph is shrinking. So it's going to start high, so above the point, and then it's going to go low. So I'm going to start high. So I'm starting up in this general vicinity somewhere. So I'm going to start high, and then my y values are shrinking. And then make sure you go through that point, and then don't touch the green line. Draw your arrows. All right, let's see if I was supposed to make this thing solid or not, since that was a mistake that I made previously. Okay, go back. There is an equal to. Okay, it's supposed to be solid. That's good. All right, so now I have my boundary. The boundary is the blue curve. You want to test something that is clearly not on the blue curve. Clearly not. And if I look, 0, 0 is clearly not on the blue curve. So I'm going to go ahead and test 0, 0. Plug it into the original inequality. So I get 0 is less than or equal to 2 times 0.4 to the 0 power. I know that anything to the 0 power is 1. Until you get to calculus, then they'll do 0 to the 0 is something totally different. And then 2 times 1 is 2. So I'm going to ask myself, is 0 less than or equal to 2? Yes, yes it is. This is true. Which means my 0, 0 point worked. So starting at my blue boundary, I want to go towards the orange. So notice that it looks like I'm kind of outside or like below this thing. So I'm going to start at the boundary, and I'm just going to go in the same direction that my arrow was pointing. And now you're allowed to go across the green boundary here. We're just shading all of the ants. So everything in this orange vicinity is a solution to this inequality. And that concludes our notes for 921 and 922.